Hi, and welcome back to Mthpt-103. Today we're going to talk about addition and subtraction of polynomials and the different parts of them. I have some definitions written on the page here. So we have a variable, which we usually use a letter or a symbol to represent. A variable is something that we don't know what its value is. We have a constant, which is something that does not change. It has to be some type of number, otherwise it would change. If you do see in generic terms A, B, C, and so on, those letters are sometimes used to represent constants, and then the end of the alphabet is used to represent variables. An algebraic expression has a combination, or could just be singles, of those letters and numbers and the variables. So we have examples of AX, BX minus C, 2.4y plus 5. There are three different examples of algebraic expressions there. An algebraic sum is when we add or subtract. So the bx minus c here up above, that would be an example of an algebraic sum, as well as 2.4y plus 5 would be another algebraic sum. An algebraic term is any term that has letters and numbers or just single parts. So here we have an expression 6y to the third minus 3x to the fourth z minus 5y over z to the third. So this is an algebraic expression, an algebraic sum. It has three terms. 6y cubed is one term, 3x to the fourth z is another term, and negative 5y over z to the third is a third term. It says, what are the algebraic terms of the algebraic sum? So 6y to the third would be 1, negative 3x to the fourth z would be another one, negative 5y over z to the third would be a third one. Those are all algebraic terms. We have some more words that we need to make sure we know the definitions of. So we have coefficient. A coefficient is the product of all the constants, normally written in front of the term. So in the 6y cubed, the 6 would be a coefficient, the negative 3 would be a coefficient in the next one, and the negative 5 in the last one. They are like terms only if they have same letters and the exponents of those letters are identical. So 8 and 5 are both coefficients, and these are like terms because y cubed z and y cubed z, they're identical. So not like terms, an example could be 2y to the third is not like 3y. They have the same letter, but they don't have the same exponent, so those would be different. I could even throw another letter in that would cause them to be different if I had the same exponent, but since this term has a z and this one doesn't, they're not like. So all of these items we've been talking about are polynomials. Some of them are monomials because they only have a single term, like 7, 3x, and 5y squared. We've had some binomials, which is 2, the 2x plus 4y. And then we have had one trinomial up above here when we were talking about the original number. This algebraic sum here, 6y cubed minus 3x to the fourth, this is a trinomial that has three parts, 1, 2, and 3. We're only allowed to add and subtract like terms, so if they're not like, we can't put them together. So we'll do a couple problems. Here I need to simplify 4x cubed minus 3yx plus 6y plus 7xy minus 7x cubed plus 8y. So this expression is saying take this trinomial and add this trinomial. When you're adding, the parenthesis really doesn't make any difference, so I'm going to get rid of it. I'm going to write 4x cubed minus 3yx plus 6y. Now there's a couple different methods for making sure you recognize the like terms. One of the methods is to do what's called stacking. Now as I look at this next expression, 7xy, and I look at this one, 3yx, they both have the same letter, and their letters have the same exponents. They're both a 1. So these are like terms. Even though their letters are in different order, I'm allowed to switch them, and now they're the same. The negative 7x cubed, same as this, x cubed. And then I have 8y, which would go with this 6y. So I'm going to add like terms now. I have a positive 4 minus 7, so I have a negative 3. Negative 3 plus 7 would be a positive 4. 6 plus 8 is a positive 14. So these are my like terms. Now, example 3 is different from example 2 in the fact that now I'm subtracting, and when I do subtract terms, they do change. So if you can kind of think about it as there's a negative 1 right here that has to be distributed. So really this problem is saying take 5y minus 4z plus 5xy. Negative 1 times 8 is negative 8, and the y tags along. Negative 1 times negative 4 is a positive 4, and the z tags along. Negative 1 times negative 7 is a positive 7, and the xy tags along. So when you're subtracting, what happens is all the signs on the inside go to their opposites. So on this one I'll show you a different method. So instead of stacking, what we can do is we can use shapes or underline, or somehow we're going to note the different terms. So here I have a 5y, and I go across and I have a negative 8y. I'm underlining them both once. Those are like terms. I have a 4z. I'm going to underline it twice. That'll go with this 4z. And then I have a 5xy and a 7xy. So I've used, they're all in a horizontal line, but I'm noting them differently by how many lines they have. 5y minus 8y is negative 3y. Negative 4z plus 4z, that wipes them out, so not even the letter will come back. It says I have no z's. 5xy plus 7xy, I have 12xy. So that is my answer. The next one is the distributive property. So as we did with the negative 1 up above in example 3, we're going to multiply everything on the inside by the 5. 5 times 3a is 15a. 5 times 4 is 20, and the b tags along. Example 5 is done similarly. I'm just doing the distributive property twice. So 3 times everybody in this group, 2 times everybody in this group. So I have 3x minus 3y. 3 times z is plus 3z. I'm going to use the stacking method on this one. 2 times x is 2x. 2 times y is 2y. 2 times negative z is negative 2z. 2x plus 3x is 5x. Negative 3y plus 2y is negative y. 3z minus 2z is z. Now in this next one we have grouping symbols, and so we have to think of our order of operations as well. Now the parenthesis here, I can't do anything, and the same here, but in front of them is a term, so I do have to do the distributive property with it, and the same with this too. So the 4a just tags along. Now I've got negative 8 times 1a, because there's an invisible 1 right here. That leaves me negative 8a. Negative 8 times 1b is negative 8b. 2 times a is a positive 2a. 2 times negative 1b is minus 2b. The 3a tags along. Now really these are in brackets. These brackets here would come tag along, but they don't really do anything. They just tell me to put like terms together. So I'm going to go ahead and put my like terms together there. So I have a 4a, a negative 8a, and a 2a, and a 3a. So 4 minus 8 is negative 4. Negative 4 plus 2 makes it negative 2. Negative 2 plus 3 brings me back to a. Now I'm going to do my b's. Negative 8b minus 2b is negative 10b. So that's all I can do within those grouping symbols, so I'm just going to get rid of the grouping symbols. I can't do anything else. So now I have this for my problem, and I'm noticing I have like terms with the b's. So negative 10 minus 3 is negative 13b. Those are not like terms, so I am done. So that's the end of this beginning part where we're just talking about adding and subtracting. The biggest thing that you have to remember is this rule right here. You can only add and subtract like terms. Do not put them together if they have different letters or if their exponents are different. And then we'll be back with multiplication.